In this video, I will show you a 2D high-speed dynamic area mill toolpath. This toolpath is used to machine pockets using a smooth, clean motion. 2D high-speed dynamic milling toolpaths utilize the entire flute length of their cutting tools to achieve efficiency in milling. They are designed to maximize material removal while minimizing tool wear. You are going to use ISCAR HEM tools. That being said, select Toolpaths, 2D High Speed, Dynamic Area. Select OK to accept the default NC name. Change the graphic view to top if needed. Leave the default settings in the chaining dialog box and pick the following chains. Once the chains have been selected, pick the OK button to exit the chaining dialog box. In the Chain Options dialog box, enable multiple machining regions to instruct Mastercam to machine all the chains. You can now select the OK button to exit the Chain Options dialog box. In the Toolpath Type page, select Dynamic Area Mill as shown. We will now select a 3/8 chatter-free end mill from the library and set the tool parameters. To do this, select Tool from the Tree View list. Click on the Select Library Tool button. Now select the New Library button as shown. Select the following tool and click the Open button. Select the Filter button. Under Tool Diameter, pick Equal and input a value of 0.375 as shown. Once complete, select the OK button to exit the tool list filter. Select the first chatter-free 3/8 end mill in the Tool Selection page. Now choose the OK button to continue. Your tool will appear as shown. Enable ISCAR HEM as shown. Now change the HEM factor to 1.25. HEM factor adjusts the tool's feed rate and spindle speed values to achieve maximum speed and efficiency. Enter a value in the field or use the slider position directly above the field to adjust it. You can enter a value from 1 up to 5, depending on the selected machine and tool configuration. Mastercam displays the corresponding feed rate and spindle speed values below the field. Input the following comment, machine all through pockets. Once the comment has been entered, select the cut parameters. This page allows you to enter values for different cutting parameters and compensation options for dynamic area milling toolpaths. Make all the necessary changes as shown. Ensure that the step-over percentage is 10. Also, make sure that the amount of stock to leave on the walls and floors is set to 0. And finally, change the percentage of tool diameter to 500. I will now take a brief moment to explain a few of these parameters. Step over sets the distance between cutting passes in the X and Y axis. While using the HEM tools, the step over can be set up as 5%, 7%, or 10% of the tool diameter. Never eliminates retracts from the toolpath for these types of tool moves. And Optimize Cut Order defines the cut order Mastercam applies to different cutting passes in the toolpath. Once your parameters have been adjusted, select the Depth Cuts page. Enable this option and input a max rough step of 0.75. Also, input a finish step value of 0.05. From here, select the entry motion. Change the entry method to profile as shown. Also, input a Z clearance value of 0.125 and a plunge angle of 2 degrees. Profile creates a follow boundary ramp entry based on the shape of the offset pocket. The slot is cleared by taking lighter cuts in the Z axis. Subsequent cuts are properly engaged at the full cut depth. You can now select the breakthrough page. Enable this option and input a breakthrough amount of 0.1. Finally, select the linking parameters. Enable clearance and input a value of 1. Also, input a depth value of absolute negative 1.25. The rest of your parameters should appear as shown. You can now select the OK button to generate the toolpath. I will now show you how to check your parts using Backplot and Verify. To backplot the operation we have done so far, select the backplot icon as shown. Backplotting shows the path the tools take to cut the part. This display lets you spot errors in the program before you machine the part. As you backplot toolpaths, Mastercam displays additional information such as the X, Y, and Z coordinates, the path length, the minimum and maximum coordinates, and the cycle time. It also shows any collisions between the workpiece and the tool. Select the Backplot tab. Ensure that the following settings are enabled: All Operations, Follow, and Leads. You can now select the Home tab. Ensure that Tool and Workpiece are enabled. Now select the Isometric View and Fit icon. Finally, press the Play Simulation button to run your backplot. Your toolpath will appear as shown. We will now simulate the operation and verify. From the Mastercam Backplot Home, select the Verify icon as shown. Ensure that Tool, Stock, and Workpiece are enabled. Now select the Play Simulation button to run Verify. Your part will appear as shown up to this point. Verify mode shows the path the tools take to cut the part with material removal. This display lets you spot errors in the program before you machine the part. As you verify toolpaths, Mastercam displays additional information such as the X, Y, and Z coordinates, the path length, the minimum and maximum coordinates, and the cycle time. It also shows any collisions between the workpiece and the tool. You can now exit Verify.